All right, let's dive into something really cool today. We're talking about that wild intersection where artificial intelligence, robots, and yeah, your kid's Lego set all crash into each other. It's an area that's just bursting with potential for education, but as we'll see, it also has some seriously surprising challenges.
So here's the big question we're tackling, right? Can a super powerful AI actually teach a child how to build and code a robot from the ground up? I don't just mean giving a few hints, I mean guiding the whole shebang. That's the puzzle we're going to piece together today.
Now, the whole backdrop for this story is the world of youth robotics, which is absolutely exploding right now. You've got these amazing programs like the First Lego League, you might have heard of it as FLL. This is where kids from as young as 4 all the way up to 16 get their hands dirty designing, building, and programming robots to tackle these really cool real-world challenges. It's all about teamwork and creativity, and it's just a fantastic way to get kids hooked on STEM.
So how do these kids even program their robots? Well, they're not typing out endless lines of code. Nope. They're using these things, block diagrams. And the best way to think of them is like digital Legos for programming. You just drag and drop a block that says move forward, then one that says turn left, and you build your program visually. It's super intuitive and makes coding way more accessible.
Okay, so you've got this awesome, kid-friendly coding setup. What's the next logical step? Well, you start asking, hey, can we bring in a super smart AI to be a personal tutor? And that right there is where our investigation really kicks off.
Back in early 2024, a group of researchers published a paper looking at this very thing. They decided, let's test the most powerful AIs out there, like GPT-4, and see if they can actually master this kid-friendly robot coding.
And what they found at first was kind of mind-blowing. When they threw traditional text-based coding problems at GPT-4, I'm talking hard university-level algorithm challenges from LeetCode, it was flawless, a perfect 100% score. Easy, medium, hard, didn't matter. It could spit out complex Java, Python, whatever you wanted, no problem.
The researchers basically concluded that the vision-capable version, GPT-4v, just outperforms other models in all of our tests. It seemed like a total slam dunk. The AI was a coding genius. But then they tried something else.
They asked it to help with those simple FLL block diagrams, and that is when they found a huge and honestly pretty shocking blind spot.
And this is the paradox they stumbled upon. The exact same AI that could write professional-grade Java for advanced competition robots couldn't correctly make the simple visual block diagrams for a kid's Lego robot. Get this, it could ace a university exam problem, but couldn't grasp the visual logic that a 10-year-old can figure out. So the huge takeaway from that 2024 study was really clear. The most powerful AIs out there just fail when you ask them to generate these visual block diagrams directly. I mean, the pictures might look kind of right, but the logic inside them was just completely broken.
For a minute there, it really seemed like a dead end. But, sometimes failure is exactly what you need. And this failure led to a massive shift in thinking, a real breakthrough in how to even tackle the problem.
The solution showed up in a follow-up paper in 2025. A new team of researchers came up with a totally new method, this time using the next-gen AI, GPT-5, which was built from the ground up to have much more advanced reasoning skills.
And here is the aha moment. It's brilliant. The old way asked the AI to draw a picture of the code. The new way asks the AI to first write a perfect logical blueprint. Then, a totally separate visual tool takes that perfect blueprint and uses it to build the blocks. So the AI isn't drawing anymore, it's writing instructions, and that changes absolutely everything.
So the theory was fantastic, a real game changer. But did it actually work when they put it to the test? Well, let's take a look at the results.
The difference was, well, it was night and day. The old GPT-4v method, it was only visually correct about 30% of the time. But the new Blueprint method with the top-tier GPT-5 Pro model, a jaw-dropping 85% success rate. I mean, performance just went through the roof on every single metric.
I mean, just look at this chart. That is a massive leap in performance. Going from 30% to 85% fidelity, that isn't just a small improvement. That is the difference between a tool that's a frustrating gimmick and one that's a genuinely useful teaching tool.
And this breakthrough, it's about so much more than just Lego robots. This is really pointing towards a brand new future for how we use AI in education.
So why does all this matter? Well, because this approach creates a true AI co-pilot for learning. It's a way to make really complex STEM subjects accessible to any kid, anywhere. You're talking about personalized one-on-one tutoring that can be scaled up to millions. And now these tools are actually being deployed on platforms like FLAI Coach. The AI is no longer just a fancy calculator, it's becoming a genuine teaching partner.
And that kind of leaves us with one last really exciting question to think about. If we've cracked the code for teaching robotics this way, what subjects should these AI co-pilots learn how to teach next? Music? History? Chemistry? I mean, the possibilities are just endless. Thanks for joining me.